Welcome and thank you for joining. We have arrived to the very last example of this very long lesson. And this time we are solving the equation 1 plus sine x equals cosine of x, where the unknown angle x is between negative pi and pi radians. So as you can see here, we have two different ratios in the equation, and we prefer to have only one ratio. So we have to think of a formula that connects sine with cosine. We know that they're related by the ratio of tan. That's because tan theta equals sine theta over cos theta. But then if we bring the tan ratio in the equation, and we've done this in the previous example, we have to divide by cosine every term in the equation. We create a tan term, yes, that's all right. And then we create a number 1 here, which is perfectly fine. But then we bring in a new ratio, that would be the secant ratio here. So tan won't work in our case, so we're going to give up this idea. So next, we have to think of another formula that connects sine and cos. And the next one to my mind that comes to my mind will be sine squared theta plus cos squared theta equals 1. Now, the problem, though, is that in our equation, we do not have a square. So what we are going to do then is think of, can I bring a square, or can I bring a sine squared or cos squared in the equation? And how can I do that? Well, in an equation, as long as we square both sides of an equation, then we still create an equation with same solutions. So we're going to do just that. And before we do this, I want to warn you of something very, very important that we probably haven't talked about in class very often, but it's a very simple concept. Now, let's say, for example, that we have a very simple equation, x equals 2. So x equals 2 is the answer. Now, if you square both sides of this equation, so x squared and 2 squared, then we create the equation x squared equals 4, right? And we say that we have applied the same transformations to both sides, so this equation must have the same solutions as the one given. Remember that this was our equation x equals 2, right? Now, if we try to solve this equation, the new equation we created, we need to square root both sides of it. So if I square rooted both sides of it, that means that the solutions would be x equals, wait a second, when we square root both sides of the equation, we have not just one but two solutions, so plus or minus 2. So it turns out that the new equation we created by squaring both sides of it created not just one but two solutions, or had not one but two solutions. So this is the case, as a matter of fact, with all equations when they are brought to the power of 2. So when we square, or when we bring equations to an even power, we create extra roots. So that is something we have to be mindful of in the process of solving this particular equation. So now let's get started. I think we're ready. So we are going to try to bring the power of 2 in. And another thing, or another approach that I chose to follow here, to use here, is bring all the variable terms to the left side. So sine x minus cos x equals, and the constant on the other side, negative 1. And now I will start by squaring both sides of the equation. So we have sine x minus cosine x equals negative 1, both sides squared, will give. Now remember, this is expanding a binomial to the power of 2. I'll quickly write the formula. I know that we remember this. So if we have a plus or minus b squared, that would be a squared. The middle term will be plus or minus depending on what we're doing here, the sum or difference of b, a and b. So plus minus 2ab plus b squared. So I know this is a very popular formula we've used in the past, but still see that you follow the long way in some cases by simplifying. So there is a shortcut to it, just a reminder. So this will give us the sine of x to the power of 2 minus double the product of sine with cosine, and then plus cosine to the power of 2. And the right side is simply 1. Now, if you notice here, we have a sine squared x and a cos squared x. They're connected to each other by the Pythagorean identity, sine squared plus cos squared. We'll bring them closer so that we can see them, how they look together a little bit better. And we have minus 2 sine x cosine x equals 1. So as you can see here, we have the Pythagorean identity, which simplifies to number 1, and minus, and here you probably recognize the double angle formula, so I will rewrite this as sine 2x. Obviously, there is more than one way to solving this equation, so if you have thought of keeping this in factored form, that can be done as well. So we have minus sine 2x, which is our only variable term, equals 1 minus 1, or 0. So that makes sine 2x equal to 0. So now what we're going to do is solve for angle 2x. Remember to find all the possible solutions for angle 2x. Recall that the domain given for x was between 0 and pi, negative pi actually, and pi radians, which will expand the domain of 2x to double of it. So we have 2x between negative 2 pi and positive 2 pi. So let's get started. Just use the calculator to find the angle with a sine of 0. That would be the angle 0 degrees or 0 radians. So draw the angle. And all we have to do now is the angles in both positive and negative domains. So remember, it's from negative 2 pi to positive 2 pi. So I created two mini Cartesian planes for the positive and negative angles because I like to draw them so I can see them better. So what you see in here is that the terminal arm of angle 0 will be on the positive x-axis. And since we use the sine ratio, the other angle will be drawn by reflecting the terminal arm about the y-axis. So the solutions that we have created here are obviously the angle 0 radians, and then we have the angle 1 pi radians, and then a third angle 2 pi radians. Similarly, here we have the angle 0 radians. This is neither positive nor negative. If you list it here, we don't have to list it twice. And then the other terminal arm will be on the negative x-axis. And now we're going to read the angles. So we have in here angle 0 radians, the angle negative pi radians, right? And the angle negative 2 pi radians. So we are going to list all our solutions. So we have angle 2x equal to 0, angle 2x equal to positive pi, or 2x equals positive 2 pi. And here we'll have 2x equals negative 1 pi and negative 2 pi. So we are solving now for x because we have exhausted all the solutions we had for the angle 2x. So we solve for x by simply isolating each equation. So here we're going to get our first solution at x equals 0. The next solution would be at x equals, divide both sides by 2, pi over 2. Next we have x equals positive pi. And lastly, we have the negatives. So we have x equals negative pi over 2 and x equals negative pi. So let's take a look now at the graphical representation of our answers. Again, we found 5 solutions here for x, and they all are between negative pi and positive pi. So you see 0, pi over 2 pi, negative pi over 2, and negative pi. So when you look at the graph of this equation, remember how we draw the graphs. So we draw the graph of the left side and the function that we create from the right side. So the graphs of y equals 1 plus sine x and the graph of y equals cosine of x. This is where they both are. As you can see, they would intersect only at 3 points. So these 3 would be the only solutions we obtain. So at x equals negative pi over 2, x equals 0, and x equals positive pi over 2. Okay, so let me just write this down. All right, and y would be equal to 0 in this case. So we are going to say that the only intersection points are at negative pi over 2, 0, and pi over 2. So the solutions that we must exclude from our entire process in here are the angles pi and negative pi. So you're probably wondering, well, how do I know which solutions to exclude when I can't graph the function? So let's say, for example, on a test, I need to know which solutions to exclude, and I'm not allowed to use a graphing calculator there. So if you want to test your answers, what we want to do is substitute the solutions inside the equation, just like we test any answers. So if you substitute x by pi radians in here, then you will get 1 plus sine pi. So remember that pi would be negative 1, so that would be a 0 equals the cosine of pi, and cosine of pi would be equal to negative 1, so 0 equals negative 1 will make no sense. The same thing happens to angle negative pi radians. So I hope